Welcome back to another video of the channel. My name is Julio. Thanks for tuning in. Before we get started, like, subscribe, hit the notification button, and let's get down to business. So today we're going to be talking about prefix lists and how to use them. So let's get inside the details. Here's a brief. So a prefix list on Cisco iOS is similar to an access list with the exception that prefix lists allow some options that access lists don't. Access lists allow you to match specific networks or subnets, but that's it. Prefix lists, on the other hand, support the GE greater and the LE less operators, allowing you to match on networks or subnets that have a certain prefix length that is greater or smaller than the certain value. Alright, so let's say you're running 192.168.0.0/16 with the greater or equivalent of 24 and the less or equivalent of 32. And you got 4 subnets running /24. Those are going to be permitted. But what about if you get something that is running a /22? That actually is not going to be permitted, and the reason is that the values that you configure on the GE and the LE states that everything that runs /24 all the way to the /32 is going to be permitted. Anything else is not going to be permitted because it's not matching any bits regarding the LE and the GE statements. Alright, so the purpose of this lab scope is going to be configure BGP peering between both routers, advertise all networks via BGP on router 1, verify routing table on router 2 to certify that you are receiving all the routes, use prefix list on router 1 to filter which networks will be allowed to be advertised towards router 2, verify router 2 routing table and verify that you are receiving only the routes being allowed. So we got 4/24 networks. Router 1 is going to be configured with a prefix list so he can actually filter whatever networks we want to advertise to router 2. So as you can see, the first subnet 10.0.0.0/24 is going to be denied and the rest is going to be permitted. So I'm actually going to provide 2 scenarios here. The first one is going to be just configuring the prefix list, and the other one, as a bonus, I'm going to configure a route map and I'm going to attach the prefix list on the route map so you can see both configuration behaviors. So without further ado, let's get inside the CML and let's get on with the lab, guys. Alright, so we're here in the CML. What we're going to do first is we're going to configure the interfaces that are going to be participating on the peer-to-peer. And we're going to configure the BGP and also bring the interfaces up because they're in shutdown state. And afterwards, we're going to configure the loopbacks and we're going to advertise everything via BGP from router 1 to router 2. Alright, so as you can see, now the BGP peering is already up, and we're gonna verify the routing table on router 2, and as we can see, we have all the networks being advertised from router 1 to router 2, reaching router 2 successfully. Alright, so we're gonna configure now the prefix list on router 1. We're gonna name it subnets, and the first statement that we're gonna configure is we're gonna deny the 10.0.0.0/24, and then the other statement we're gonna permit the 10.0.0.0/16 with the greater or equivalent 24 and the less or equivalent 32. So that means whatever matches those bits regarding the values that we configure on the GE and the LE is going to be permitted. Anything else is going to be denied. Alright, so we're going to go right ahead to the BGP instance, and we're going to type the command neighbor 192.168.1.2 prefix-list subnets. That's the name of the prefix list, and we're going to configure it in the outbound direction. Alright, I wanted to show you this. As you can see, router 2 is actually receiving all the routes still, and that's because we need to do a clear IP BGP star soft out on router 1 so everything can take effect. Remember, BGP is slow, so as you can see now on router 2 routing table, we can see now that the 10.0.0/24 is no longer there, so it's being filtered, and everything else is being allowed regarding the prefix list that we configured on router 1. Alright, so I'm going to show you now how to configure prefix list using route maps. As you can see, router number 2 is receiving all the routes without no filtering, and that's because I already erased the prefix list on router number 1. So we're going to get started on the new configuration. And just to show you, I'm going to do a show run pipe session BGP so you can see the configuration that is already running on router number 1. As you can see, the prefix list is not configured on the BGP instance. Let's get started with the new configuration. So this is going to be a little bit different now because the route map is actually the one that's going to decide if the prefix is going to be allowed or denied. Alright, so we're going to go ahead and configure the prefix list with the permit statement for the 10.0.0.0/24 network. Keep in mind, as I said before, the route map is going to decide if it's going to be denied or permitted. So we're going to go ahead and create the first route map with the sequence number of 10 with the deny statement. We're going to bind the prefix list that we created to the route map, and we're also going to create another route map with a sequence number of 20 with the permit statement. We're going to leave it with no configuration, and by default it's going to permit anything else. Alright, so we're going to go now to the BGP instance. We're going to type the command neighbor 192.168.1.2 route-map BGP. That's the name of the route map, and we're going to configure it in the outbound direction. We're gonna do a clear IP BGP star soft out. Jumping into router number 2, and as you can see on the routing table, the 10.0.0.0/24 is being denied and the rest is being allowed. If you like the content, please give it a like, and as always, this is Julio. I'll see you in the next one. Peace out.